Hello everyone, this lesson we're going to discuss a ground fault detection system using the 3 PTs on a delta system. So here the connection, I have a 3-phase 3-wire ungrounded delta system. I connect 3 PT in there and the 3 lamp and the alarm relay in this circuit to do a ground fault detection. My supply 3-phase 3-wire. Line voltage 14.4 kV. The PT have a ratio of 120 to 1. Then they're going to ask you to calculate the normal condition, the voltage across each lamp and the ground fault alarm relay, and calculate when there's a ground fault happens in the circuit, what going to be the voltage across those. So let's look at this circuit. The PT, the primary side, is connected in Y because one of the terminal is common connect onto the ground. The secondary of the PT is connected in delta. So under normal condition, the primary side, the line voltage is 14.4 kV. Because the PT is connected in Y, so the primary phase voltage going to be line voltage divided by root 3, 14.4 kV divided by root 3, give me 8.314 kV. So across each of those PT, the primary side only got 8.314 kV. The secondary side of the PT, the phase voltage is going to be primary voltage divided by the ratio, give me 69.3 volts. So under normal condition, each lamp going to say 69.3 volts. And the alarm relay is connected in a way to do the delta closure test. So when we usually connect a delta secondary 3-phase transformer, we will put a voltmeter down here to measure what's the close voltage down there. When everything connected right, your delta closure test will read 0 volts. So under normal condition, the alarm relay is going to have 0 volts. That's why it's not going to send in any alarm to indicating ground fault. Then if we have a line A have a ground fault condition happens. When line A have a ground fault, so line A we have the same potential as ground, or ground we have the same potential as line A. So basically line A and the ground is connected. Then PT1 we have 0 potential across its coil because the 2 terminals of that PT1 now it's connected together. But the PT2 and the PT3, now we have the line voltage across its primary terminal. So on the PT2 and the PT3, the primary side, the phase voltage equal to the line voltage equal to 14.4 kV now. Now the secondary phase voltage is going to be the primary phase voltage divided by the ratio, going to give me 120 volts. Because PT1 have 0 volts across the primary side, so the secondary side of the PT1 also have 0 volts. Lamp A going to receive 0 volts, going to become totally dark, and the lamp B and the lamp C going to see 120 volts. Compared to the before 69.3 volts, lamp B and the lamp C going to become much brighter. And the alarm relay at this moment, because we only have 2 transformer, 2 PTs working, so become open delta. The alarm relay, we say the open delta voltage, it's also same as the line voltage on the secondary side. So the alarm relay, we say 120 volts. When alarm relay receive 120 volts, you're going to send the signal to the alarm to indicate there's a ground fault situation happens. So here's how a ground fault detection system with lamp and alarm relay works. And one more thing I want to emphasize is if we have a CT in the circuit, you should never open the secondary of the CT, or the CT's secondary should never be open circuit. Because if there's a primary current in there, the secondary of the CT going to induce a very high dangerous voltage. It could cause safety hazards. The voltage could reach few thousand volts. So never open the secondary of a CT. If you have any question, you can connect us online or send us emails.